Assalamu alaikum warahmatullahi ta'ala wa barakatuh, ladies and gentlemen. Welcome back to another live stream. Right, let me share the link with my server. Please join my server so you can vote on next live streams, and also you can get notified. Right. Okay. There you go. Right. So I shared the live stream now. Pretty cool. Lovely. All right, let's go. Okay, so pretty much going to continue on the previous live stream, pretty much. So previous live stream, this is what we got so far. Let's debug this. Okay, it's compiling since I switched my toolchain into nightly last live stream, so that's why it's compiling from scratch. Okay. Right. There you go. So we basically got this little animation right here, only of course using Vulkan Ash extension. Pretty much, and we didn't even use any graphics operations. In fact, like we didn't need like shaders or any of that. I just done it like in the simplest way possible without any extra craziness, just make it work on my machine essentially. I didn't even handle a lot of edge cases, which may make it not work on some other platforms. So but yeah, it works. So let's go ahead and actually check Vulkan Caps Viewer, not that. Yeah, I want Vulkan Configurator, right? There you go. And let's check the validation messages. There are probably going to be a lot right there because we have missed some things. For example, the layouts. We haven't transitioned the image into a proper layout, into presentation layout. So I guess let's try that next. Basically right now we got this working version. Let's hopefully make it more robust. Let's see. So overriding layers by default configurator, and let's check out the validation layer. Okay, and yeah, let's go. All right, as you can see, there is a lot of messages right there, so let's just check them out. Okay. Validation error. Required parameter p submits 0.pwait dst stage mask specified as null. The Vulkan spec states if wait semaphore count is not 0, pwait dst stage mask must be a valid pointer to an array of wait semaphore count valid combinations of vacate pipeline stage flag bits values. Okay, let's check the other one. There is an invalid image layout. There you go. That's what I was talking about. So command buffer expects vacate image to be in layout, vacate image layout transfer, DSC optimal instead. Current layout is actually vacate image layout indefined. All right. So we have to actually do or use two barriers to actually switch the layout of the image to the proper one. So we'll see about that in a second. Image path to present must be in layout, vacate image layout present, or shared present. There you go. As I said here, let's go. What's next? But does not have the vacate command will create reset command buffer bit set. Okay, we also have some problem with the command buffer. Although all these problems, but it still worked. So that's something. Okay, what's next? Validation error, the same one right now. Draw state invalid image layout, same thing. I think same thing here. Yeah, so these messages right now are just being repeated. But let me see if I can actually remove the repeated messages real quick. Stateless parameters. There's a lot of cool stuff here. Best practices, debug output. I could make it break like in the program, in the debugger, trigger a breakpoint basically. Whenever I get an error, but we don't need that now. I'm not enabling info currently, but you can enable that for extra information. Okay, warning, performance error. All right, max messages, view ID. All right, so that's pretty much it. There's no way to actually do that. Okay, never mind. All right, so let's work on this. First of all, let's try to basically fix the image layouts using image barriers. And let's go ahead and do it. I'm gonna bring, of course, the documentation. There's no way I memorized the whole Vulkan spec. So let's check Vulkan barrier. I don't even remember which barrier exactly we're gonna need, but we'll see. Yeah, there you go. I think this one, maybe. Let's see. Buffer image. There you go. Cool. Insert a memory dependency. To record a pipeline barrier, call vkcmd pipeline barrier. Let's go. So command buffer, it needs a stage mask and a destination stage mask. Dependency flag. Now, honestly, as you can see, it's really wanting me to go the easy route of just graphics. So and I think this would pretty much get very complicated real quick. So honestly, instead of trying to fix this, I guess let's just go ahead and try to basically use right now the graphics path of doing things. So by basically making a pipeline and stuff like that, and to hopefully render a triangle. So let's not waste a lot of time at this point, I think. But yeah, so let's go ahead and do that. So we're gonna remove this command clear color image. We're not gonna need that anymore. What else? Wait for fences. Swap chain extension, Q present semaphore. Okay, we got the swap chain images, cool. We're also gonna need frame buffers, though later on I'd like to try, what is it even called? Dynamic rendering, which wouldn't even require frame buffers and a lot of crazy stuff. But let's just go ahead and do that. So let's start by frame buffers, I think. And for that, what we're gonna do, we're basically gonna go through all the swap chain images. So swap chain images dot map. Map what? Map the swap chain. Oops. The swap chain image. And let's actually check that out. Device create frame buffer. Okay. So it's gonna need frame buffer create info. Let's go ahead and give it to it. Oh my god. There you go. Vk frame buffer create info. Builder. And let's see what it actually needs. It needs a render pass first. So yeah, let's actually make a render pass first, really. Okay, let's just count this for a second. And let's make a render pass. So render pass equal to unsafe. Well, let's just say device create render pass. Let's check that out. So vk render pass create info. Builder. And okay, there's all these things that we have to handle. pnext subpass s type subpass counts. Interesting. Well, honestly, you know what? Let's start with the pipeline. Let's start with the pipeline anyways. Let's start with the shaders. So pipeline is equal to create pipeline, okay? Device create pipeline. Well, it's graphics pipeline layout. Let's start by pipeline layout actually. It's gonna be vacate pipeline layout create oopsies create info builder. And for this one, we're not gonna give it anything really. So that's something, I guess. But we will be changing that later on. But for now, we don't need any of it. So with that, we get a pipeline layout. Oopsies. There you go. So we got a pipeline layout now, I think. Provide. Oh yeah, I forgot the allocation callbacks. None. Okay, and let's surround it with save block. Okay, cool. Next up would be, well, let's check what we need else for a pipeline. So device create graphics pipelines, and the pipeline cache, we don't need that now. And create infos, okay? So I'm going to say as ref. Oops. What is it called? From ref, I think. There you go. It's basically std slice from ref. And here we're going to pass in the graphics pipeline bit info. There you go. And let's go with the builder. Space pipeline index, space pipeline handle. We don't need any of that. And there's flags, layout, pipeline layout. There you go. We got that. So pipeline layout. Right. And by the way, I did change some things from the last live stream, which is just that I added for every object I create, I added this scope, and basically anything that is not needed afterward, I just put it inside of that scope. Basic, for example, the surface capabilities, I'm not going to be using it afterwards, so I just put it inside of this scope. Same thing with the other guys, basically. Not much have been changed though. But anyways, so let's actually grab this create info from here, honestly. Let's see. Graphics pipeline. Okay. I think this should be in safe. Well, we need some arguments first of all. Some extra arguments. With the allocation callbacks, which is none for now. And what else? Just run save block. And the pipeline cache, well, we gotta do this. Vacate pipeline cache, oopsies, null. Okay, what else? Right, that's the, well, that's gonna give us the pipelines, and we don't care about that. I mean, we're only gonna be creating one, so let's just get the first one. So first of all, let's unwrap it, and then into iterator, I want to consume the vector, I don't need it anymore. And then let's get the first pipeline. And basically we're gonna say context, no pipeline, and yeah. So I just converted the option to a result there. Cool. Okay, layout, and what's next now? So we're gonna need the, okay, let's see. There's stages. Well, There's also render pass that we're gonna need actually. All right, well, just to keep things simple, I think I'm gonna follow up with the Vulkan tutorial. All right. So if you go here, drawing a triangle, graphics pipeline basics, shader modules. We're gonna need shader modules later on. Yeah. Well, honestly, let's handle those first, pretty much. Yeah, let's handle those first. It's gonna be crazy. Okay. Pipeline layout, no pipeline. The trait bound is not satisfied. What do you mean? Can I grab this? All right, if that's okay, let's just enwrap it. And what else? Okay, let's go ahead. Create graphics pipeline layout. Let's actually create the shaders. So let shader module. Oh well. We're gonna say device create shader module. Here you're gonna give it the common none. Oopsies. There you go. And then here we're gonna need vacate. Reference to. Oh my god. There you go. And vacate shader module create info builder dot. Okay, so you're gonna need pcode code size. So for that, we actually gonna need to load files first. That is crazy. Oh well. Let's just count these things for now. Let's actually first of all load in some shaders. So we're following up with this guy. So we're gonna have a simple vertex shader. For now, we're not gonna be using any buffer. We're just gonna be embedding the vertex data in the shader itself for now. Later on, we can actually try to create a buffer. That's a little bit more complicated. But anyways, let's just try to say new directory assets and new file shaders. Oh, actually not shade. Hold on. Let's actually create a directory called shaders. And yeah, now we're basically, now I'm gonna have two things actually. I'm gonna have like dev assets. Or honestly, let's just keep it simple. Let's just, yeah, whichever. And then here, let's just say shader.glsl or shader vertex. Well, let's say vertex shader, I guess. Hello from Melbourne, Australia. Programming Siri. Hello, hello. Welcome to the live stream. Okay. Vertex shader GLSL add. And we're gonna add this vertex shader and let me install some plugin to have some cool stuff there. Okay, accept. All right, cool. Now that's the vertex shader. Let's actually create a fragment shader. .glsl add, and let's go with the fragment shader. I'm gonna be explaining these later on, but right now we're just gonna be loading them. I thought the Zig programmer. I saw the Relib tutorial was good. Thanks for sharing. You're welcome. You're welcome. I actually program in a lot of languages. I program in Lua, in Rust, in Zig, in C, C++, C Sharp, Java, you name it. So that's something. Okay. So that's a fragment shader right there. Cool. Now we're gonna actually, you're gonna need the vertex as, sorry, not the vertex, the Vulkan SDK. And thank you so much, programming Siri. Okay, so we're gonna need the SDK. so you can have access to the shader compilers. Otherwise, we could actually go ahead and compile them at runtime. Interesting. Should we compile them at runtime? I mean, we can if you want to, using, what is it called? Shader C. Yeah. So if we go to Rust crates, let's look for Rust crate shader C, I believe. And there is a library that could actually compile it at runtime for us. Rust bindings. This is not an official Google product. Yeah, this pretty much this crate right here. Is it still not abandoned? Well, IDK, let's see. Repository, let me make sure that is the case. Don't want some problems. February 5th, 5. Well, that's suspicious, but I guess maybe it should be fine. I mean, let's try it out, I guess. Let's try it out. Okay, let's actually go ahead and copy, well, shader C. Go ahead, let's add this library. Shader C 0.8.2. This is the version that I'm using right now. And let's actually, yeah, there you go. There is some stuff here. So, well, I guess it is expecting a string, right? Compile options, compile into SPIR-V. It needs the file name, the source, which is basically the string. So yeah, let's actually first of all load the files. So let's go ahead and do that. Well, where is the stuff that I was doing? Oh, not yet. Okay. Let's just do it here. Okay. So let's see how we could actually do a file in Rust. Well, it's gonna be fs, right? Yeah. So let shader, like vertex shader file, I guess, is equal to std fs maybe. Yeah. And let's see how we could actually open a file. I do remember though there was some cool function that could, yeah, read to string, exactly. Which you basically give it a path and it just gives you the string directly of the shader, which is pretty cool. That's what we need. So we're just gonna go with assets slash, well, at least I hope so, slash shaders slash vertex shader.glsl. Now you don't really need this. You don't really need to include shader C, and it's actually pretty heavy. It's pretty large. Well, kinda. Um, so if you don't want to, like, it really depends on your thing, on your use case. If you add it, you're gonna be able to like load shaders at runtime and stuff like that, which is kind of cool. But if you don't, you could just use like shader C as a command line tool. Let's see, shader C. Well, it's not recognized. Interesting. I mean, let me just go to my Vulkan SDK. You're gonna find your Vulkan SDK. Let me find it. Okay. Yeah, there you go. So in your local disk, you're probably gonna find Vulkan SDK there. You're gonna go inside of it, and there's bin, and there's some compilers here like DXC, which you could probably use to, I guess, compile HLSL shaders to SPIR-V. It's basically DirectX compiler. There's GLSLC, which is actually shader C, which we're going to use right now. And there's GLSL lang. All of these you could actually use to compile stuff with. I mean, let me show you CMD, and you could say glsl lang.exe, and there you go. There's also shader C here. Well, it's called GLSLC. Oops. Hold on. What? Yeah, no input files. And well, I actually already shown that. Interesting. What is the other one called? GLSL lang. Okay. There you go. Same thing with the other one, and also DXC, same thing too. But we're just gonna do it at runtime, honestly, using shader C. Okay, let's see how we can do that. So we're reading the vertex shader source from a file there, and then, okay, and let's grab the fragment shader source, and let's try to print line this stuff just so I can show you. Okay, so it's gonna take a while, I guess, to compile. Oh, well, that was fast, but could not find the path specified. Interesting. What if I said src slash weird? Okay, that worked. Let's see. There you go. As you can see, I actually printed it here, which is nice. So we could actually put the assets outside of the source. Okay. And then we don't even need src right now. Just like that. Cool. All right. So now we have the vertex shader and the fragment shader source. What else we're gonna do? We're gonna go ahead and compile them up at runtime. So we're gonna basically copy this up to somewhere around here, I guess. And let's see what's happening. Did I add it yet? Yes, I did. So we just need to import these, I guess. Huh. Why I can't import it? Interesting. Weird. Maybe I should say use shader C. But that doesn't seem to be the case either. Crazy stuff. Let me try to reload that. Let's see if that would help. Nope. Weird. Okay, I think it works now, right? Yeah, it does. Okay, I just had to reload that. Interesting. So here we got the compiler and the compile options, where you could basically add some stuff to it. And like, for example, here they're adding a macro definition, but we don't actually need that. There's binary results, compiler, compile into SPIR-V. Here's the source code. We're gonna go with vertex shader source. And what's going on here? Found string, okay. So let's convert that. Well, what? Let's just give it the address, I guess. There you go. And it's vertex shader. And the file name. This is, I think, just for debugging purposes, though. So you could just say something like this. Just copy it over, I think. And yeah, the entry point name, mostly you'll always leave it as main, though you could use this, I guess, to like put the vertex shader with the fragment shader in the same file. But yeah, in wrap. So that's pretty much it, I think. Now this should give us the binary result that we're looking for. By the way, let's just remove this for a second. Let's try to print line this. Let's see what's gonna happen there. See? Oh yeah, no, it cannot actually do that. Well, just give me the length. there. Just so I can make sure it is running properly. Yep, there you go. We got the binary. Cool. So right now we have compiled the shader at runtime pretty much. So that's nice. Now this is basically a vertex shader. Oops. Binary. And let's do the same thing as the fragment shader, though we don't really need to create multiple compilers, just one compiler would do. Fragment shader here. Fragment shader binary, same thing. Fragment shader source. Okay, well, hold on. This guy, put it here. And this should be fragments instead. What else? And here, this should change to the fragment shader source, basically. So yeah, mutable compiler. Okay, so right now we got both binaries. Now we could actually create shader modules. So vertex shader module is equal to device dot create shader module vk shader module create info builder. Oops. And here you need to give it the p code and the code size, or you could use this function right here to give it a slice, which basically going to be the vertex shader binary as binary. Oops, what's happening right now? Okay, what? Oh yeah, I still have to give it another argument, which is none here. And let's go. Okay, what? Still need something. She's probably in safe, yeah. And what else here? Expected. Yeah, let's just add a reference here. And there you go. Yeah, all right. So that should basically give us the shader module for the vertex. Now, same thing pretty much for the fragment. Copy, paste, fragment. And let's go with the fragment shader binary as binary. Because honestly, this is not really a binary, but this is like a compilation artifact. And let me just see what we could actually get out of that first. As binary, you could say get number of warnings of compilation, get warning messages. Interesting. Yeah, that's pretty much it. So yeah. So this is not really binary. This is like just, I don't know, compilation. Well, artifact, I guess. I'll just call it that. Okay. As binary. Okay. So right now we got the two shader modules. Next up, let's see what we're gonna need. Right, there you go. So compile the shaders, loading shaders, blah blah blah. Yep, we have done all that. Shader stage. Okay, let's create the shader stages. So let shader stage, well, vertex shader stage is equal to, well, in fact, we could indeed make this into its own kind of function, honestly. So I guess let's do that. Maybe fragment shader mode. But honestly, it's gonna be crazy. Well, never mind. Let's just do it inline. Okay. So vacay vertex shader. Oh, oops. Shader stage. Pipeline shader stage create info builder. And let's go with the stage. This is going to be shader stage flags. There you go. Oopsies. Let's go. And this is going to be vertex. And the next step it would be the module, which is the vertex shader module. What else? There's also specialization info, which we don't need. There's also p name, which you also need to provide. And this is going to be a C string, I think. Oops, hold on. There you go, dot name. It's going to be, yeah, it's going to be a C string. And for that, you're going to actually say, well, std cstr, I think. Oops, ffi cstr from bytes until null. I think it's probably with null. Create a C string wrapper. If the null byte, okay, so let's just use this. And right here, we could actually give it the bytes, which is basically gonna be, oh my God, that's a lot. Hold on. Let's just add a semicolon there. There you go. Okay, let's see how we could do this. It's basically gonna be main, but let's not forget about the null character at the end, basically. So yeah, and it also should be a B here, basically bytes. Expected CSTR found. What it found? Hold on. Expected CSTR founders. Oh yeah, I forgot to actually unwrap it. And there you go. That's basically how you do it. That's the name of the entry point. Okay, let's just basically do the same thing for the fragment shader. Fragment shader stage. Okay, seems good to me. Yep. All right, so what's next? What's next? Okay, let's go back. So what we need next, so we got the vertex shader stages on, cool. And we're just gonna need to create this stage create info slice. So yeah, no need for now. Okay, go next. So right now, we're just gonna fill up the other stuff like dynamic state, vertex input, etc. So let's go ahead and do it. So now let's actually go back to this guy. So we already have created the shader modules, cool. And now, what's happening here? Create graphics pipeline from ref. vk graphics pipeline create info builder. Then we got the layout. And let's see what's next. Can we say modules or stages? Hold on, what? What's happening? Oh, okay, I see. So now let's give it the stages. Yep, there you go. And we're just gonna give it like a slice. Bruh. There you go. And let's give it the vertex shader stage and the fragment shader stage. Pretty much. And Type mismatch expected, found. Okay, let's actually make this into its own thing, I guess. Let's shader status. There you go. Then we could just give it a reference to that. Or we could give it like a slice somehow. Okay, what about shader status? Oops. What about that? Maybe 0. What about this? So expected pipeline shader stage create info. It found the builder. Oh yeah, I see. So basically we have to build these stuff manually because they are in a actual array. So that's something. Okay. Can we just do this? Yeah, it seems like we could just do this. It was this problem right here. Okay, cool. Also, can we actually do it like this? I don't think though. Yeah, no. Okay, we got the shader stages set up now. What's next? Let's see. Okay. Let's start, I think, with the dynamic state. Let's go ahead and do that. So the dynamic state, what this gonna need? Pipeline. Dynamic state create info, builder. And let's check this out. Pretty much we're not gonna have any dynamic state. Well, except for viewport, maybe. Well, currently we don't really need that, so that's, yeah. Pretty much don't need that currently. Yep, pretty much it's set in viewport and scissor, but I don't need that since I only have like a fixed window, not resizable window. So, okay. Let's just grab the reference of this guy. And that should be done. Next up, who's else? Vertex input, let's go. Vertex input state, reference off. I wish if the if the autocomplete was like more smart. But anyway, we could actually even give it a default value. I wonder what the default value would be. Interesting. Though, can it actually give it? Hold on, what? Interesting. Anyway, let's just do it manually. Builder, and here we could actually give it the vertex attribute descriptions and stuff like that, which we're gonna need in when it comes to buffers and stuff. So yeah, but we don't need it right now, so that's fine. Okay, what else? Vertex input state. There's also input assembly. Right, input assembly state. Builder. And what we need here. Okay, there's primitive restart enable, which we don't need. There's topology. This one is important. Let's go ahead and give it the topology that we want, which is pretty much going to be triangle. I don't really recommend anything else other than a triangle list. Yeah. What else? We of course need a reference here. Okay. Do I need anything else? Let's see. Yeah, I don't think. Yep, pretty much just the topology. The viewport. Okay. Now, what's next? The viewport state. Which is going to be a reference of vacate pipeline. Oopsies. Viewport state create info. And let's go with the builder. and viewports. And here I need to give it a slice of viewports. I only have one, so let's say from ref, and just gonna say this std, well, nice, vk viewport builder, and here we gotta give it like the height, the width, etc. So let's go with the width, which is gonna be, well, interesting. So let's say window dot, I guess, physical size or something like that. Let's see. Inner size. Yeah, there is inner size, which actually gives us physical size, and it is important to be physical size. Okay, that would give us width and the height, which is nice. So let's just grab that and let's just say window size is equal to that. Dot width. And what's wrong? Expected F32, but found U32. Interesting. Let's actually cast it to F32. And let's give it also the height. Same thing. Window size dot height as F32. And there you go. Cool. Okay, what else? So these are the viewport state. Okay. We also need the scissor, right? Right. Yeah. Let's see the scissors. So viewports, scissors, and same thing here from ref, and reference of vk scissor. Oh, it's rect2d. Okay. Alrighty. So let's create a rect2d builder. Let's go with the extent, and that's gonna be the window size, hopefully. Well, it needs it as extent 2d. Interesting. So let's give it an extent 2d. Builder dot size, I think, or what? Width and height. Okay, I gotta give it one by one. So window size dot width as f32. Oh, oops, that's fine. Okay, and next up is the height, which is gonna be window size dot height, and there you go. Though, let's actually build that. There you go. That's it for that one. Now what's next? So we got the viewport and the scissor ready. What is the next step? Pipeline. Viewport, yeah, rasterization. Okay. I wanted to follow up with this tutorial because it's you cannot like keep track of all these properties. But yeah. Anyways. So I'm basically keeping it as a reference essentially. Keeping it as a reference. Oopsies. So now let's see the rasterization state. Okay. Vacate pipeline rasterize. Okay. Create info, and let's go with builder. And the builder helps me with that. It like provides you with all the possible stuff. Though I think I'm only gonna need here front face and call mode. These are pretty much seem like the important ones, and also the polygon mode, right? Yeah, pretty much. Let's go with the polygon mode first, I guess. This is an enum, I think, and let's go with the fill. If you need to use some other stuff, then you gotta like enable some features. like GPU features in your device, but anyway, we don't need that. Front face, well, I recommend going with anti-clockwise or counterclockwise because that's the standard mostly, though you could always use clockwise too. Right, what else? There's also call, which is also important. So vacate call mode flags, and you could either call the front face or the back face, or front and back. Now, you'd ideally want to call the back face, so like the face of the triangle that is not visible to the user wouldn't be visible, like wouldn't be processing. So you save up some power right there. But just for the sake of debugging, I'm gonna go with front and back. Why? Because sometimes you may get something wrong and then you don't see anything, but you're actually just somehow seeing the back face instead, which is called. So just for safety, for now, we're gonna go with front and back, but later on, when all it works, we're gonna go with back. We're calling the back face. Okay. What else? Right. I think I don't need anything else. Yeah, line width 2 front. Okay, let's go with the line width 2. So that's gonna be 1.f0, and pretty much that's what you want to set it up as, because if you want to use anything else, I think you gotta enable some other, or I think maybe something that is greater than 1, then you probably want to use another feature, device feature. Anyway, next up is pretty much sampling. Which of course we're not going to use. Multi-sample state for now at least. Vacate multi-sample state. Great info. Builder. And let's see. So there is a lot of cool stuff here. Let's see. So pretty much all these optional. And only thing I guess we need is rasterization samples for now. And let's see, sample count flags. Well, okay, let's go with type 1. Is that 0? No, that's 1. So you actually need that. It's not, that's by default. Okay, cool. What's next? Depth and stencil testing, color blending. All right, color blending. So color blend state, reference of vacay color. Oops, actually it does give me the, cool. So it's actually smart. Great. I just didn't notice, I guess. All right, lovely. So the only thing I guess we need here is, oh, hold on a second. No, this is actually only the color blend attachment. Is it? Interesting. So no, we need something else. Yeah, so color blend state, create info, attachment state. Okay, interesting. So we need some attachments here basically. So there's blend constants, flags. So yeah, we need attachments, I think. There you go. And we only need one attachment pretty much for now. Reference of vacate pipeline color blend attachment state builder. And for this, I think we're only gonna need the color right mask, which we're basically gonna set to everything, to all the components. I wonder if it can help with that. Doesn't seem like it. So yeah, let's just do it manually. So we're gonna need the R. Oopsies. Well, R, and we're gonna need the color component flags, G. Oops, and or basically here you tell it like which components you want to use. B, and I guess also A. Yeah, And there you go. Okay, great. Do I need anything else? I don't think so. That's probably it for now. Though if I want to handle transparency later on, I gotta actually go back to this. Anyway, this seems fine, I guess. Yeah, next, well, this is what we have done, in fact. Optional, attachment count, optional. Yeah, pretty much that's it. And the pipeline layers which I have already created. And yeah, finally, I think we're done. Yep, pretty much we're done with the pipeline, I think. Let's check this out. So this should hopefully create a pipeline successfully. And let's check this out. So honestly, for the command pool and the command buffer, I'd like to actually create them before uh, everything in maybe after the device. Where's the device? There you go. Well, after the queue. Okay, cool. Or honestly, let's just leave them where they were. Or never mind. Here's. Okay, let's just run this and let's see. Let's find out what's gonna happen here. Though, actually, I don't want to run the event loop just yet. I just want to see if the pipeline would actually work. Oops. Oh well. Oh well, oh well. Queue present. Let's actually just comment all this out for a second. I just want to see if the pipeline would work out just fine. Data provided is not null terminated. Okay. But where this is coming from? Oh well, interesting. Right, so let's see. Let's try to find where's the problem. Let's not create the pipeline for now. Okay. Let's just comment this out for a second. Let's see. Okay, it's not the pipeline. I knew it. It's probably this shader stage stuff. Maybe this stuff right here. Let's comment this out for a sec. Because I don't have some stack. Well, this seems fine. So probably the problem is one of these guys, I guess. All right. Well, yep, I think so. So if I do this, what's gonna happen? Would it crash now? I think it would. Interesting. So it's probably here. Is this backslash? Maybe not. No, it wasn't backslash. Okay, so that's the problem. I thought it was a blacks. Okay, well, never mind. Let's just comment this out. And where is that thing? Oh my god, where's the... What? There you go, okay. So let's make it a backslash instead. And yeah, let's try it now. We should have a pipeline now. And use of indeclared type color component flags. Where is it? Yeah, let's just use vacay for this. Okay, 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 okay. Okay, we got some crazy stuff going on here. Access violation relocation. Okay, interesting. Create graphics pipelines. So yeah, it's basically in create graphics pipeline. Register. Okay. Access violation. Reading location 0xFFF. Well, crazy stuff. Interesting. Let's try to use the validation layer. And let's see. Yeah, where's the actual, there you go, console. And let's try to figure this out, I guess. Oh yeah, I forgot about the render pass, right? Yep, it's not a valid render pass. Though it's happening to multiple shaders provided for stage. Okay. Seems like I provided the same. Hold on. Vertex. Okay. Oh yeah. This should be fragment. That's one thing. Alright. And we still need to create a render pass to actually able to create a pipeline. Okay, let's go ahead and do that. It's gonna be next. So there you go. Okay, let's create a render pass. Let render pass is equal to and safe as always device create render pass. What's happening? Oh, create render pass. Here we're gonna, of course, as always, need this render pass create info builder dot. All right, let's see what we're gonna need. Probably gonna need first of all the attachments. It's gonna be one attachment, so let's just say from ref vk attachment description. Let's go builder, and let's see. So the format would be color format, and the layout. Okay, let's see. So let's start with the format. The format, by the way, I forgot to change it in the swap chain too. Yeah, last time I had changed this. I need to make sure it is color attachment. And with that out of the way, for the format, I'm just gonna go with B8, well, vacate B8G. What's going on? Oh, yeah, formats. There you go. sRGB, exactly. What's next? Let me add a semicolon there so I could save. Oops. Okay. What's next? Probably let's go with the initial layout. For the initial layout, it's gonna be, well, it's gonna be color attachment optimal because we're gonna be writing to it as a color attachment in the shader. And what's next? It's gonna be final layout. Now for the final layout, we're gonna go with present src khr, I believe. Or is it present DST? I actually don't remember. Let me see what he's gonna do here. Yeah, present src, exactly. Why the initial layout is set to undefined? Interesting. I don't think they should be undefined. Weird. Anyways, I'm just gonna go with my version. Okay, what's next? We also need samples. Well, we only have one sample. We're not using multi-sampling yet. Type 1. What else? There's also Lloyd OP, which is gonna be Lloyd. And there's also store OP, which is gonna be store. So we do want to store it, and we do want to, actually we don't want to Lloyd it, I think. Yeah, don't care, I think. Hold on. Actually, yeah, we need to clear it, in fact. Yeah, we need to clear, my bad. So here, instead of Lloyd, we can clear it with a color, basically. And we're gonna store it. The other stuff, the stencil stuff, we don't need those right now. So we're gonna go with attachment load OP. Basically don't care. And stencil store OP. Don't care too. So AK stencil P. Oh, what's happening here? All right. What else? And by the way, let's give it a reference here. Okay, what else? What else? What else? We gave it the format, the stencil, the initial layout, and the final layout, and there you go. Cool. Lovely. What's happening here? Yep, I need to give it the allocation callbacks as always. So for here, we're gonna give it none. What's happening? Oh, see. And there you go. That's it for the attachments. Let's see what else. Now, let's see the, I guess, subpasses. Hold on. Attachments. Here, attachments. Well, we already have done the attachments now, I think. Subpasses, exactly, and we're gonna have one subpass. Subpass description. Builder. And let's see what we got here. So yeah, we're gonna have one color attachment from ref. Well, attachment reference. Okay, attachment reference. So the attachment would be 0, and the layout would be color attachment. And that's basically it. Of course, as always, reference. And I think that should do the trick. Attachment reference. Yeah, pretty much we just need those for the attachment. And yeah, we're done with the color attachments now. What's next? The input attachment, we don't need it. Color, we have done that. Preserve, resolve. And yeah, we need also the pipeline bind point. Yep. For that, it's gonna be graphics as well. We're gonna be using in the graphics pipeline. And yeah, that's pretty much it, I think. Well, we still need to give it the dependency though. So we gave it the attachment description, subpass and attachment references, the render path. P subpasses. Yeah, we're still gonna need the dependency. My brain hurts. Okay. Hmm. Probably also need dependencies, right? I think it's gonna do them later on, but let's see if I can figure it out real quick. Builder. Yeah, we have the source subpass, the destination subpass, and the dependency flags, access mask. Let's leave those until later, until he does them, because I can't really remember exactly what it was. So, okay, so that's pretty much it for that one. We just gotta unwrap that, and we got a render pass. Now we could pass it up to our pipeline. Render pass. Simple as that. Huh, what's happening here? Two arguments were supplied. What? Hold on. Oh, render. Oh, hold on. I'm doing something wrong. Yeah, the render pass. There you go. Okay. Now here I could actually pass it in the render pass. Great. And yeah, that's it for the render pass, I think. Well, we still need, as I said, the dependency, but should be fine for now. Oh yeah, we still have that panic. Let's try to figure out why. Probably have missed something. In fact, we have missed something. But the problem is what is. That's crazy. Create graphics pipelines. But what is the actual... Oh, it just failed, basically. Okay, I see. But what it failed with exactly, that's the question. It's an error. Where's the error? Let's go to the console, I think. And error unknown. What? Okay, no entry point found named main for stage vacay shader stage fragment bit. Oh, interesting. Hold on a second. Well, I'm setting the name for both. What's happening? That matches the stage. Oh, hold on. Can I check the fragment shader? Yeah, both are using main. So what's wrong? Well, fragment shader artifact main, vertex fragment, vertex shader source, fragment shader source. Weird. Problem is the fragment. Okay, hold on. So basically there's some problem in the fragment stuff. So we're getting the right file, so that's nice. We're also compiling the right file, right? Yes, we are doing that. Oh, okay, I see. Fragment shader module is not being used. Amazing. Okay, let's see why. Yep, there you go. So that was the problem all along. Let's see now. And yeah, right now we're finally making a render pass, a pipeline, and all that crazy stuff. Cool. Now, by the way, we could actually get rid of the vertex shader stage and fragment shader stage and all that stuff after we create the pipeline. But anyway, for now, I'm not really gonna care about that because it's, well, it's not really like I'm actually not caring about destruction of objects right now at all. Like, as you see, I'm not handling any of that. But honestly, we can do it here. It's like just after creating the pipeline, uh, we don't need to keep those around basically. So the vertex shader module dot destroy, I think. Let's see what's happening here. Oh, sorry, device dot destroy shader module, and then you give it the modules. We don't need them anymore. And the destroy shader module, also the fragment shader, of course, we don't need that too anymore. And let's actually make these in safe. Provide the argument. Yeah, the allocation callback. Interesting. Let's add none there and none here. Now we're just gonna make sure that this is surrounded with and save block. And yeah, that should be fine. But of course, you can only destroy them because we don't need them anymore since we have already created the pipeline that wanted to use them. So let's just make sure nothing funny is happening. Yep, seems all good to me. Now let's go to the next step. Well, right now we actually have the render pass, so we can start creating the frame buffers. So that's something. Let's actually create frame buffers. So for the frame buffers, we're gonna say, well, I wonder if it's image views or image. Hold on. Or actually, let's just go with this guy and let's see. Pipeline info, blah blah blah, all that. Destroy pipeline, blah blah blah. Okay. Let's go to the next stage. Frame buffers. Yeah, there you go. So for frame buffers, what do you need? Is it the image or the image view? Yeah, the image views. So we already got the image view. Actually, we don't got, like, I mean, I did it last live stream, but I just removed it because we didn't use it. But right now we actually need it. So yeah, let's create the image views. So swap chain image view is equal to swap chain images dot map. Oopsies, map closure. Oopsies, map image to an image view. Well, how we do that? Well, device dot create image. Okay, image view create info. Let's go builder dot image, and let's just pass it in the image. And since we actually need the image itself, we could just say copied. Doesn't really matter since, you know, it just let's first of all say iter dot copied, because it's just a handle, it doesn't matter copying them. And yeah, what's happening here? Surrounded in save block, and none here for the allocation callbacks. And this would actually give a result, so let me just unwrap it. And that should give us the image. But before that, in fact, we need to collect it into a vector. And we're going to infer the objects that are inside the vector. There you go. We got vector of image views. Nice. All right. What's next? We need the swap chain frame buffers, or basically buffers. So for that, we're going to say it's kind of a similar thing to this guy. But anyway, swap chain image views dot well, iter, well, not really, let's just say map iter dot map, right? And oh my god, there you go. And then we need the image view here, and let's just say device dot creates frame buffer. Now here, reference off vk frame buffer creates info, builder dot image view. Oops, what's happening? What is it called? What? Oh, I think. What? Yeah, it's attachments, I see. So yeah, I see. So basically you could have multiple image views on a frame buffer. So let's start with the render pass actually. There you go. Next up would be, by the way, this is in safe. And what else? In rep 2, and here we need the none. And yeah, what's going on here? Okay, now let's actually provide the attachments. Oops. Okay, we gotta provide them here. From ref, we only have one attachment. What's happening? There you go. And here, let's give it the image view. And here we only need the reference, not really a whole image handle. So that's nice. Okay. I think that's pretty much it, really. Render pass. Do we really need width and height? Well, I mean, if they... And we also need layers, of course. Probably this is going to be one layer, and width and height. And this is going to be... oh, not that. Right? Do we need width and height? Yeah, we do. So let's actually set it to image, well, window size dot width. Oops, this is 1, right? But this is window size dot width. There you go. And here window size dot height. And there you go. Done. I think that's maybe it. Yep, pretty much. And of course destroying, which I don't care about now. All right, and right now I'm just gonna make sure to collect in a vector, and we're done. So right now we pretty much got the frame buffers too. Lovely. Let me make sure just that everything is going well so far in terms of errors. Okay. So there is some validation layers here going on. Oh my god. Okay. Oh, sub-resource range, aspect mask. In Viki create. Oh yeah, I see. I see. So let's go back to image views here. Create image view, right? Let's see what we have here. So yeah, it's not just image. We also need some other stuff. So like there's format, which is pretty much the swap chain format, BGR8 sRGB. Next up would be the image format components. I don't think I need this. Flags, type, sub-resource range, and view type. Let's go with the view type. Yeah, type 2D. We have a 2D image, not a 3D image, or something like that. And the other one is sub-resource range. I can actually explain a lot more, but as you can see, there's just a lot that goes into this. And yeah, we do not have too much time, but if you want me to explain this, like to go back when I'm done with this, to go back and make a stream where I explain the whole thing, let me know in the comments. So, okay, let's see the aspect mask. Image aspect flags, color, isn't it? Yep, it is. I mean, is this even? Yeah, this is fine now. What else? What's happening here? Oh, let me give it a reference, I think. Or hold on, this, what it takes. Oh, it actually takes a whole, it's not a reference. So let me actually build this. There you go. Well, other than the aspect mask, let's see. By the way, before we needed like the pipeline barriers and stuff to make it work properly, but right now we don't because the render pass would actually do that for us automatically. So that's nice. Okay, what else? Layer count 1, level count 1, and I think that's basically it. I think that's it. So, what's next? See if we have any problem right now. Validation error. No validation error, so pretty much we have done the pipeline and image buffers, all that. Well, not image buffers, but image view stuff. Okay, next up, command buffer. I've already done this, but yeah, I do remember there was like a problem with validation because I forgot to add some flags. Since we're gonna be re-recording the command buffer every time, like every frame, we gotta add a flag there, which is, I think, hold on, where can I actually do it? Yeah, it is in the command pool basically. So create command pool. We only have key family index right now, but let's set the flags. Here you go. And yeah, let's go with probably reset command buffer. Is also transient, which is not applicable here. That's probably what we need. I mean, let me check what this guy does. Yep, there you go. Create reset command buffer bit. Let's go. This is basically hints that command buffers are recorded with new commands very often. Oh, oops, not this one. This is transient. Allow command buffers to be recorded individually without this flag. They all have to be reset together, pretty much. So yeah. Actually, do we really need that? Yeah, pretty much. So, okay, what's next? Command buffer recording. Oh yeah, let's go. Now, yeah, we gotta start a render pass. Interesting. Render pass begin info. Okay, so right now we actually go to the command recording stuff. So pretty much we need to deal with this guy right here now. Pretty cool. So begin command buffer in wrap, and then I have here in command buffer. Okay, let's actually do device dot begin rendering. No, that's dynamic rendering. Begin render pass. There you go. And here we need to, of course, give it the command buffer as always, and then we need the command render pass begin. So reference of render pass begin info builder. Let's see what we need. The render pass, pretty easy. Here's the render pass. Okay, what I need else? The render area, the frame buffer, Okay, right now I need to select the right frame buffer depending on the image index. So that's pretty simple. I'm just gonna say frame buffers. And then I'm gonna give it the image index so I could get the frame buffer of the current frame that we're processing right now. And of course they should be as size because it's U32. And yeah, that's it for the frame buffer. Next up would be I think the render area and the clear values. Yeah, let's go with the clear values, maybe. And for this one, I'm just gonna have one. Well, we only have one attachment, so okay, vacate clear value. Let's go. And here we're just gonna say default. I don't care really about clear value currently, though later on we may want to care about that. Okay. What else? The render area, that would also be important, I think. Vacate rect 2D, builder, extend. Okay. This needs an actual rect 2D, right? Yes, it does. So we need to build it. And then extend 2D, builder. And let's go with the width and the height, okay. So for the width, it's gonna be like window size, width, and yeah, and the height would be window size dot height dot build. All right, that's pretty much it for that one. Is there anything else I missed? Render pass, frame buffer. Yeah, that seems it. That seems it. Okay, I need some other parameters. What are those parameters? The subpass contents. That's the enum. Okay, we're just gonna go with inline. We don't have any secondary command buffers here. Okay, great. So right now, hopefully we have begun a render pass. Well, of course, whenever you begin something, you have to end it. So let's go ahead and end it too. Let's pass in the command buffer. That's how you end a render pass, as simple as that. Okay, cool. Now what we need to do with this render pass. So clear color, blah, blah, blah. Anyways, yeah, we need to bind the pipeline now. Okay, let's bind the pipeline. So let's bind our only pipeline that we have. Command buffer, pipeline bind points. This is an enum, which is gonna be graphics and the pipeline. Because, well, pipeline objects is just generic. It could be a graphics, it could be compute. So every time you need to use the pipeline, you need to tell like what pipeline bind point is. Like, is it compute or graphics or whatever. So anyways, let's just give it the pipeline now. And that's pretty much it for that one. What's next? Yeah, and render pass. I don't need to set viewport because I didn't make it as a dynamic state. I just set it in I baked it into the, what is it called again? Into the pipeline directly. So yeah, and yeah, that's pretty much it. I don't even need scissor to, yeah, also we want to draw, we want to render. So device.cmd draw. And here we need to give it the command buffer and how much vertices we want to draw. We want to draw 3 because we're drawing a triangle. And then one instance, and the first vertex 0, and the second vertex is also 0. This is kind of like a slice, but in the C way. But anyways, so that's the command draw. Well, all of these are in safe. Okay. So, okay, cool. And end command buffer. What's next? Synchronization. Oh yeah, I have to actually think about synchronization now. Queue submit, wait for fences, blah blah blah. Image available semaphore. I think it is about time to actually call our semaphores in a good way, I guess. So where are the semaphores? Here we go. Let's actually grab them down here. Let's grab them down here. Okay. So this would be like image available semaphore. So when we have an image available, it would be signaled. And also render finished semaphore. Oopsies. Render finished semaphore like this. Okay, I need to do the same thing here. Right. Semaphore. And that's pretty much it. Render finished semaphore. Now, basically what we need here, need to make sure, like when we acquire next image, we want to signal this image available semaphore. And before we start the rendering, we need to wait for that semaphore. And how we're gonna do that? Well, when we actually try to submit that, let's see. There you go. Wait on the semaphore, image available semaphore, and please, when the rendering finish, please signal this semaphore. And there you go. Now for the presentation, we need to wait for the render to finish, and then we can present to the screen. And of course, we're also waiting for the in-flight fence. That's what they call it. In-flight fence. So yeah, there you go, there you go. Of course, we need to reset it every time we use it. And I think that's pretty much it. Reset fences, cool. Find image from swap chain, reset commit. Oh, okay. It's able to be recorded. Vacate reset command buffer. Honestly, hold on a second. Hold on. Device reset. Okay, I could actually reset a whole command pool. Now, honestly, since I only have one command buffer, I don't really need this flag, honestly. This would basically just allow me to like only, instead of like resetting the whole command pool, I can reset an individual command buffer. I don't need that right now as I only have one command buffer, but I know why the author have done that in the tutorial, because later on he's gonna do like multiple command buffers, so that's why he done that. But right now, let's go step by step, and let's just use reset command pool instead of command buffer. So yeah, command pool, and here we need command pool reset flags, and here we need oh, do we need anything? Not really. So command, I guess empty. Hold on. But of course, when we're gonna do that, well, after I guess we used that guy. Hold on. Well, what's going on here? Oh, in flight fence. There you go. And when we're going to reset that guy? Well, you need to reset it like after you're done with it, like after you're done with its submission, which would actually happen after we present. Ooh. No, hold on. After the render is finished, I think. Is it? Yeah, after the rendering get finished, I think. Yep. So what we could do, we could just, after we waited for the in-flight fence, I guess we could go ahead and reset the command pool there. The author though just resets first and then, but anyway. Okay, so for this one, let's just unwrap it. Basically gives a result. And what else? Yep, I think that's it. Okay. All right, what else? Let's see. Submitting the command buffer. Oh, the wait stage is interesting. So we need to wait for the stage color attachment output bit. Where exactly? Wait stages. Interesting. In the render stuff, right? Signal semaphores. Yeah, wait stages, color attachment output bit. Where is that guy? Q submit. There you go. And let's add that. Wait this destination stage mask. Okay. Basically, we're telling it that we want to wait for the image available semaphore, I guess, in the color stage, maybe, something like that. Anyways, pipeline stage flags. So for that one, I think we only have one. And here, what we could do, yeah, it is expecting a slice. Okay, vacate pipeline stage flags. Color attachment. Oh, I see. I see. Color attachment output bit. Just waiting for the output. Well, I still don't really understand it very well, but anyways. Anyway. Okay, what else? Subpass dependencies. Oh yeah, they're back into the render pass. There you go. This is the dependency that I talked about. So they're gonna wait for a subpass external. Yeah, I see. So let's go back into the render pass real quick. Where's the render pass? Come on, come on, come on, come on. There you go. Render pass dot. Oh, not here. In the info. Where is the info stuff? Create render pass. Okay, here. So dependencies. Let's create dependencies from ref, I think. Vacate subpass dependency. Here we're gonna basically be describing the subpass dependency, though we only have one subpass, so that doesn't really matter, but we still have to like synchronize or like tell that there is a dependency on the previous subpasses of the same render pass. But anyway, who cares? It's basically source subpass is actually external. What's this supposed to be? Hold on. U32. Oh, what? Oh yeah, subpass external. There you go. There you go. And what else? We also need the destination subpass, basically the first one, 0. Okay, what else? And then we have the source stage mask. We're gonna wait for the color attachment output bit. Basically destination also that. For the access mask, it's gonna be 0. Okay. Well, I honestly still don't understand this very, very well, but anyway, I kind of understand a bit when it comes to this subpasses and crazy stuff like that. But anyways, you don't even need to really understand it most of the time. So, SRC access mask, stage mask, unless if you're doing something crazy or using multiple subpasses. So stage flash color attachment bit. Now destination access mask. Here we're gonna need the attachment right bit. Yeah, because we're gonna write to it, I think. Hold on, what's that? Oh, access mask. Color attachment right. Yep, exactly. And then we have the dependency count. Yeah, that's pretty much it. Pretty much it. What's happening here? So we need to give it a reference. And yeah, access mask. Well, let's say access flags or oops, there you go. And here it needs to basically be, I guess, empty, which would basically be 0, I guess. Maybe. Yeah, because it's bit flag, so that makes sense. All right, so I think that's basically it for the dependencies. The presentation, we have already done it. Image indices, yeah, pretty much. So right now it should hopefully be done, unless if I missed something. So let's see. And we're getting nothing. Hold on. Oh, okay, let's see. Uh, we have some validation layer stuff. So, validation error, destination stage mask. Destination stage mask. Oh, did I miss that? Yeah, I pretty much missed that. Yeah, I see. Which should basically be the same. Because it's basically the same subpath, just the next one or previous one. Yeah, pretty much, I think. And for that's the one for that. Next up is destination access mask. Is not supported by stage mask. Okay, what about invalid image layout? Command buffer expects vacate image to be in layout. Color attachment instead is undefined. What? Weird. Okay. All right, let's try this again. Let's see what it's gonna tell us right now. Expects, well, command buffer expects, so this is in submits command buffers, okay. Expects vacate image to be in layout, vacate image layout, color attachment optimal. Okay, I'm missing something here, I guess. Well, that's good enough, I think. What is the actual... Hold on a second. Where do we set the layout again? Do we need to set it here? No, we don't know. Okay, let's check out where we're setting the layout. I think in the render pass. And right, let's see. So the initial layout, color attachment optimal. And the final layout is present srckhr, which is correct. Here I'm setting the layout to be color attachment optimal. Which is also correct. So what's wrong? Create graphics pipeline, render pass, frame buffers. Can I see this? Hold on a second. Is there some layout or something here? Nope. So that's not relevant. Okay, I'm missing out on something. Command buffer. Right, we don't actually need this variable right here. So we're beginning the command buffer. Then we're beginning the render pass. Passing the render pass. We're binding a pipeline. Drawing, ending the render pass. Then finally ending the command buffer. Then we're submitting command buffer. So somehow it didn't like this. Interesting. Okay, let me see the errors again. Command buffer expect vk image to be in vk image layout color attachment optimal. Instead, current layout is vk image layout present. What? That is interesting. Crazy stuff. Well, let me check all the image layouts stuff. So color attachment optimal. Final layout. Present source HR. I mean, that should work. I have no idea. Yeah, somehow Vicky image. So where this is exactly? Draw state invalid image layout. Validation error. Wiki object p submits 0 command buffer. Expects image to be in layout wiki image color attachment optimal. Set current layout is image layout undefined. Pretty weird stuff. Draw state. Very weird. The render pass is actually supposed to do that. So create frame buffer. Image view. Can I actually see the image view real quick just to make sure something? Where's the image view? There you go. Okay, aspect mask, color RGB. I don't think this is. No, it's not. Something fishy going on here. I'm beginning the command buffer. Then I'm beginning the render pass. I guess let's um, hmm. Okay, let me make sure that I'm doing the render pass right. Or honestly, let's go back a step and let's make sure we're doing this right first. All right. Oh, wow. Hold on. Wait stages. Huh? Wait. Well, wait DST stage mask. That's exactly what I'm doing, yeah. So that's not it. All right. Okay, let's see the other stuff. This is irrelevant. Irrelevant. All right. I don't think this is relevant at all. Though, hold on, let me make sure that this is right. We're beginning the render pass, then we're binding the pipeline, then we're drawing, then we're ending. That's exactly what I'm doing. Yep. Begin, command buffer, render pass, pipeline, then drawing, then we're ending the render pass, then we're ending command buffer. Hmm. Yeah, let's go back where we're actually creating the render pass. Let's just make sure that is right. Oh, well, he's actually setting it to indefined somehow, which doesn't make any stupid sense. Since we're going to clear it anyway. Present source. Okay, go back. I don't think this is even a problem here, but I mean, let me make sure. Color, image layout, and oh, what? Hold on. Yeah, something weird here. Okay, let's just go with indefined here. That's the first thing. And of course, the final layout is present src. I don't think it would work though. At least not yet. Oh, why we're not getting any error right now? Crazy stuff. Huh. What? Okay. Well, we're not getting any error. I think maybe I've done something. Hold on. Go to the call mode. Oh my god, I'm calling front and back. My bad. I should have said none. That's what I meant before, but we need to call back. Let's try this now. And yeah, still no triangle. Bruh. What in the world? And right now we're not even getting any errors at all, which is weird. But let's go further. Let's make sure we have all the values right. Because, well, this is probably the problem. So color attachment optimal for the attachment reference thing. Let me make sure that is the case. Because, yeah, probably the render passes, we're missing something there. Essentially, we're clearing and storing. Color attachment optimal, which is correct. Yep. Okay, where the other stuff then? Yeah, let's also check that too. So it's Lloyd OP clear store OP store store OP store Lloyd OP clear. Yeah. Stencil indefine. Like don't care. I mean, yeah, that's another level. Like what? Oh well. We're not even getting errors now. And it's not working. Amazing. Let me make sure. Okay, we're resetting the command pool. Q present. We're waiting for the render finished semaphore, and here we're signaling it. Okay. Requiring image available semaphore. Okay. Hold on a second. What's going on here? Begin. Where were you using this guy though? Okay, we're waiting in the queue submit. Nice. And we're signaling here, waiting here. Bruh, I just don't get it. Like, that is another level. Yep, pretty useless. Waiting for fences. Bakery reset fences. Bar next image. Reset command buffer. Boarding command buffer. Okay. Submitting the command buffer. We already checked this one. Now this subpass dependencies. Maybe I got something wrong here. I guess let's double check. Other than that, really don't know. No, let's go back to this call mode stuff. Can I just say none though? Just to make sure. Yeah, that may be the problem actually. There you go. Oh my god, finally. I know the problem now. Oh my god. Well, there you go. We got the triangle. Let's go. The problem this whole time was the calling. So basically, to make this work right, so the tutorial basically is actually using clockwise, but we were using anti-clockwise. That's why. Now to fix this is easy, which is to basically invert the positions of these guys. So this would go here, and like basically the first would go to the end, and then the end would go to the first, so as to invert it, because we only have three elements. And of course, since we have only three elements, the second element will stay in the same spot. Now we do not hopefully have to actually set this to none. Right now we could hopefully set this to back, and it should work out just fine. And let's go. So now we're calling the back face, and it's actually working. Oh my god, I can't believe this. That was crazy. There you go. Pretty much done with the stupid charm. Right. Alright. Um, there is one little thing, which is we don't need this variable. And yeah, there's some other stuff that we could also do, like the in-flight fences later on, the frames in flight, and the swap chain recreation. But yeah, for now, for this live stream, I'm tired at this point. Goodbye, everyone. Thank you for watching and see ya. Goodbye.